the last class, we have discussed on the types of solid waste and the resources of solid waste and the relation between the types of solid waste and their sources. And then we have seen what are the different functional elements of solid waste management. In that we are having six steps. So that is waste generation, waste handling, sorting, collection, then transfer and transport, then separation and processing, and then disposal. We have discussed regarding this in detail, and then we have covered what are the factors affecting generation rates. Okay, in today's class we are going to continue on with the solid waste management and overview, which is going to have these six steps. Then the characteristics of solid waste, that is, it is going to have physical, chemical, and biological characteristics, and each one will be having the few points in it. So we are going to discuss in detail regarding this in today's class. So we will see regarding what are the solid waste management overview. Okay, now the main objective of a solid waste management, as you know, that we try to minimize the disposal of waste, and we try to reduce the impact which is going to be caused by throwing or dumping of these solid waste into the environment. Okay, now to assess these particular or to have these particular objective, we need to have these particular six steps. In that, first is the material flow in the society, then a reduction in the raw material usage, reduction in the solid waste quantities, then reuse of the solid waste material, then material recovery, then energy recovery. If we are having all these six things, then we may be able to reduce the quantity of solid waste, that whatever we are going to dispose, we can reduce it. Okay, now first is the material flow in the society. Okay, now solid waste are generated at the start of any of the processes, right from the mining, and thereafter the solid waste are generated at an each and every steps. Okay, that whenever we are going to extract the raw material, and from extraction of raw material, then if we want to produce one particular material, till the end of that particular product, we will be continuously generating some amount of waste to the environment. The best way is to reduce the amount of solid waste is to reduce the consumption of the raw material and increase the rate of recovery and reuse of the waste material. That means whatever the raw material we are going to extract in order to produce a new material, that we need to reduce it. How we can reduce it is, if we can able to have the if the recovery and the reuse of the waste material. That means instead of throwing the waste to the environment, if we try to reuse it, then what is going to happen is the new material requirement is going to be reduced. When the new material requirement is going to be reduced, we will be requiring less amount of raw material in order to produce the new material. So that if we require less amount of raw material in order to produce a new material, then automatically we are saving the environment by generating whatever in each and every process of the production of material. We will be saving whatever the at a different steps, whatever the waste we are going to produce, that we are going to reduce if we are going to increase the rate of recovery and reuse of the waste material. So by having this material flow in the society, that if we are going to reduce the usage of new raw material, that is in the production of new material, if we reduce it by having the reusing and by having the increased rate of recovery, then we will be able to reduce the material flow in the society. This particular first point that we have covered it now. Then the second point is the reduction in the raw material usage. To satisfy the principle of conservation of mass, that is, the mass input must be equal to the mass output. It clearly states that if the reduction in usage of raw material is to occur, either the input or the output must be reduced. Okay, now the output when it is going to get reduced is when our requirement are going to be restricted, then we require very less amount of material. Then what if we require very less amount of material for our day to day usage, then ultimately what we are going to do is whatever the input or the whatever the raw materials that we require in order to produce the new material, that we are going to reduce. The raw material usage can be reduced effectively, and by reducing the quantity of the municipal and the industrial waste, whatever the raw material we are getting it for the production of the new material, right, we should use it very efficiently, we should not waste it. Okay, then if we are not going to waste the raw material usage, then we will be reducing the raw material whatever is required in order to produce the new material. Then the third is reduction in the raw solid waste quantities. The third point is reduction in the solid waste quantities. In this, this can be achieved in three ways. The amount of material that is used for manufacture of the product, that can be reduced. Okay, then the useful life of a product, if we are going to increase how the solid waste quantity can be reduced is, if we whatever the, suppose if you are going to use one particular material, and if it is going to be spoiled within say 1 month or 2 months or say 6 months, then what had happened is the useful life of that particular material has been reduced. Now if we instead of using it for 1 month, 2 months, 6 months, if that particular material, if we produce the quality material, and that particular quality material, if it can be utilized for 3 years, for 3 years, 4 years, say 5 years, if we are going to do that, then what we are going to do is we are giving the less solid waste to the environment, as well as whatever the raw material production we or whatever the raw material is required for in order to produce the new material, that raw material we don't require, because what we have done is we have increased the life of the useful life of the product. By this we can reduce the solid waste quantity that we are going to the environment, as well as along with this we are also reducing the raw material the usage. Okay, the amount of material used for packaging and marking of the consumer goods can be reduced. If we are going to reduce the, or if we are going to increase the useful life of the product, then of course when a material is going to be produced, what we want some of the packaging materials in order to transport that produced new material. Automatically when we are going to increase the useful life of the product, then we are not going to produce any new kind of a product. For that new kind of a product, we don't require any kind of a packing and marking or any other instruments in order instruments or the things or stationaries, whatever we want, we don't require all these things. So what we are going to do is we are going to reduce the solid waste quantity which is going to be generated in order to produce a new material, or during the production we can reduce it. Okay, then the reuse of the solid waste material. See, if we want to reduce the solid waste that is going to be generated in the environment, we should always have an aim to reuse the material again and again. If we at once usage only, if we are going to throw it, then ultimately what we are going to do, we are generating too much amount of a solid waste, and we are giving it to the environment, which is spoiling our environment, as well as again we want again the raw material in order to use the new material. Okay, so by this both way we are going to harm the environment. So if we want to reduce the both way harm to the environment, we should have the habit is we should reuse the material if it can be reusable again and again. Okay, so this is regarding the reuse of a solid waste material. Then material recovery. Now most likely for recovery and recycling, most the material which can be recovered is your paper, cardboard, plastic, tin cans, aluminium, and some of the ferrous metal, glass, etc. So we should always have an habit to recycle these particular material, whichever material can be recycled, we should have the tendency to send it for the recycling units instead of throwing it and disposing it to the environment, so that what we are going to we can save some of the raw material things that are required for production of new material, as well as your the whatever the solid waste we are going to throw it to the environment, it can be reduced. Then energy recovery, because about 70% of the components that that consist of solid waste are organics. The potential for the recovery of energy is high, that we can have the biogas from this, and we can incinerate some of the waste material, and we can get the energy out of it. We can get the electricity, we can get the heat energy out of it, and we can utilize it for the different purposes. So this is regarding your solid waste management overview. In this particular overview, what I wanted to say is, we should think to reduce the raw material usage. We should think to reuse the material. We should try to material recovery and energy recovery, so that in both way we can prevent our environment by spoiling of, or by using more amount of raw material, or giving more quantity of solid waste to the environment. So this both way we can save our environment by using less amount of raw materials, and by throwing less amount of solid waste to the environment. So this is an overview of your solid waste management overview. Now we will see some of the Indian scenario, that how we are going to produce the solid waste material, and we are going to see some of the Indian conditions. In India, the Indian cities will normally generate around 50 million tons of solid waste per day. Okay, the urban population, which is less than 1 lakh, it is going to generate around 0.3 kg per day solid waste. It is per person per day is going to generate. That means in a population which is going to have population less than 1 lakh, per person is going to generate around 0.3 kg of solid waste per day. And the population which is more than 50 lakh, it is going to generate, per person is going to generate around 0.5 to 1 kg per person per day. He is going to generate the waste. Now we are observing there is an 70% of the increased volume in the garbage due to the usage of packed food in plastic, aluminium, and then water bottle, then canned cold drinks, milk sachets, then chips in pouches. So what is happening is, here once we are going to use it, we are going to directly throw it to the environment. As due to all these such kind of a waste material, what we are going to do is, we are increasing the 70% of garbage to the environment. And the punch of lower cost, then carry bags, plastics, by using all these elements, we will be increasing the waste to the environment. Okay, then Mumbai generates around 6,000 tons of solid waste per day. Then there are around 73 municipal corporation and 1770 municipalities in India, which is according to the 1991. We are going to have the one dustbin for around 130 to 2400 people, which is very very less. And due to this, we are going to have the less amount of solid waste management, and we are going to see some of the unhygienic conditions that we are going to have. Then the distance from house to dustbin is normally around 50 to 500 meters. So again, one sweeper per 500 to 1000 people. And then the rack pickers collect around 12 to 20% of the total solid waste which is generated in India. They in fact helping the government by picking the recyclable material and sending it to the recycling unit. Okay, then some of the problems that we are going to have in India due to the in case of solid waste management is the lack of funds, lack of appropriate technologies, no stricter rules, and corruption, and then attitude of the people. We are generating too much amount of solid waste. Now we will concentrate on the characteristics of solid waste. That is, we are going to have the three characteristics in solid waste, that is the physical, chemical, and biological characteristics. In physical characteristics is having three parts in it. That is, first is the identification of individual component, then particle size, then the moisture content. We will see what are things are involved in the physical characteristics, and then first is the identification of individual component. Here, see, we are going to get the mixed solid waste. In case of our municipal solid waste, we are going to get the mixed waste in this. So what we need to have is, we need to bifurcate this into the dry waste and wet waste, and along the according to the category, we need to separate the waste material in it. Then food waste, we need to separate it, we take it separately. Paper waste, we need to take it separately. Then cardboard, like this, whatever the waste material, one category of the waste material, we need to separate it. And then we should, what if we are going to do this, then it is, whenever the recyclable materials, we are going to send it to the recycling unit, we will be putting less strain during your recycling or reprocessing whenever we do it. Then in case second is the particle size. When we send the material for the recycling unit, what we should do is, we are doing shredding, then screening, then we will be, basically what we are going to do is, we are going to separate the waste material based upon its size. For that, we will be having shredding, screening, disc screen, magnetic separator, all these things we are going to do it. So whatever the size we want for the recycling process, or for that, we are going to depend upon this particular particle size. Now here, in order to solve the problem, you have seen that we have solved the problems on moisture content and density. In order to solve those problems, these two things are important. So what is moisture content? Okay, moisture content means it is the present of some it shows that there is the liquid is present in the solid waste. So we are going to determine in terms of percent. We are going to measure this in terms of percent. Now we are going to measure by the moisture content by using this formula, that is, moisture content is equal to A minus B divided by A into 100. Now what is this A? Now A is nothing but the initial mass of the sample delivered, and B is the mass of the sample after drying. Now the solid waste, whenever we want to determine the moisture content, what we are going to do is, we will be taking the initial mass of that particular sample as it is when it is going to be delivered. Might be it is going to have some of the moisture content in it. So if we are going to get some waste material, we are going to, as it is, we are going to weigh it, then it is going to represent the initial mass of the sample as delivered. That is nothing but A. Okay, now what is B? Now whatever the material we have got it, if you want to determine the whatever the moisture content is there in that, then what we are going to do is, we are going to place it into the oven. The material A, we are going to place it into the oven at around 70 or say 80 degrees Celsius for about 24 hours. And what happens due to it, whatever the moisture content that particular material was having, it is going to be evaporated. So we are going to get the new weight new weight B. A is the initial mass of the sample, B is the mass of the sample after drying. After drying means, A, we are going to keep it in the oven at a temperature of around 70 to 75 degrees Celsius for about 24 hours. If you are going to keep at that particular temperature, whatever the moisture content is there, that is going to be vanished. So how we can determine the moisture content which is present in that particular waste material is, we are going to determine it by A minus B divided by A into 100. 100 is nothing but we are going to calculate this in percentage. Okay, I hope you have understood this particular concept of the moisture content. Okay, then usually the food waste will be having the higher amount of moisture content than paper, cardboard, as these are a bit, they are not going to absorb too much amount of moisture. They will be having less amount of moisture content in it. The food waste, as it is biodegradable, it is going to have more quantity, more amount of moisture content in it. Then again garden, again it is biodegradable material, it is going to have more amount of moisture content. These are the example of moisture content. The food waste will be having around 70% of the moisture content, whereas your garden trimming will be having around 60% of the moisture content. Wood will be having around 20, and paper, it might be it is going to have 6, cardboard 5, plastics 2, then glass again might be it is less than that. So this is regarding your moisture content. Now we'll see what is the density. Now when the density is going to come into your mind, you will be first thinking about think regarding the unit that we are going to use. It is mass by volume. Density is nothing but mass by volume. Okay, so the unit is, it is kg per meter cube. Okay, the unit for the density is kg per meter cube. Now we are when we want to have the solid waste into, suppose if we want to have some heap of solid waste which is there in this particular heap, if we want to have this particular solid waste in the container, okay, what we are going to do it, we are going to place it into the container. Are we going to place as it is? No, what we are going to do is, after placing it here, we will be trying to compact it. So what we are going to do it, we are increasing the density of the solid waste material by compacting. Okay, the density is equal to mass by volume. Now what we are doing, we are increasing the we are going to increase when we want to reduce the volume, we are going to increase the density by reducing the volume. How we are going to increase the density? By compacting it. By compacting it, we are going to increase the density of solid waste, and then we are, by compacting it, what is going to happen? The waste material is going to get suppressed. So when it is going to be get suppressed, what we are going to have is, we are getting less volume. The material is going to be compacted here. We are going to get the less volume, and we are going to increase the weight of the solid waste. We are going to increase the density. So this is regarding your the density. Then we will be seeing your next. We will see the chemical characteristics. In this, we will be having the proximate analysis, fusing point of ash, then ultimate analysis, then energy content. Now, what is the proximate analysis? Right, for the proximate analysis, we will be having the four components in it. That is the moisture, which we have already seen, then volatile combustible matter, then the matter which can be which is going to be having the ignition or at around 950 degrees Celsius, or nothing but we call it as a volatile combustible matter. Then fixed carbon, we are going to get it. Then ash. So this is regarding the proximate analysis. Then fusing point of ash. The second point is the fusing point of ash. It is defined as, right, the temperature at which the ash is going to be result from the burning of the waste, okay, which will form a solid clinker. That means when we are, it is the temperature at which we are going to, ash is going to get a form, right, and which is going to form the solid clinker by fusion or agglomeration. This temperature is going to range between around 1100 degrees Celsius to 1200 degrees Celsius. Then the energy content, we can get the energy content in kilojoules per kg. The unit for this is kilojoules per kg. Then we are going to get it from your full scale boiler. Then by using the bomb calorimeter, okay, we are going to get the energy content. Now the energy content, the calorific value, it is we are going to get it from the calorific value. The calorific value is going to be get defined by the amount of heat generated by conversion of the unit weight of a substance. It is going to be expressed in kilojoules per kg. Next is your energy. In ultimate analysis, we will be having the fixed amount of, in particular material, how much amount of carbon is there, how much amount of hydrogen is there, how amount of oxygen, sulfur, nitrogen, the different elements, how much quantity it is there in terms of percentage, that we are going to have in the chemical ultimate analysis. Then we will be coming to the biological characteristics of a municipal solid waste. It is going to have the biological characteristic, means it is going to in some of the waste material, it will be having sugar, starch, amino acids, different organic acids, then hemicellulose, cellulose, then fatty oils, waxes, your alcohol, lignin, right, or proteins. Okay, so all these together will be called as the biological characteristics. So this is regarding your physical, chemical and biological characteristics. So in today's class, we have seen then a solid waste management overview, Then we have seen how in India how we are managing the solid waste, that is an Indian scenario. Then the characteristics of solid waste, we have seen physical, chemical and biological characteristics in today's class. Thank you.